We built a real-time machine learning system with FHIR and DICOM, and I work with Stratus Medicine, lead this group that really works with startups, small business, health systems, and payers to work on software engineering and innovation projects, generally around machine learning. So in this project, we worked with this Ku Foundation's Sun-Yat Cancer Center, which is a premier cancer center in Asia, just outside of Taipei. They're a 325-bed hospital, and they provide both inpatient and outpatient oncology care. And they've actually been operating in value-based care, bundled payments, and oncology for decades. So they've made some very interesting investments in technology. And specifically, I'm going to talk about trying to early detect breast cancer metastasis in their patient population. So if you're not familiar, breast cancer metastasis is when the original cancer spreads to other parts of your body. And what we're trying to do is identify in follow-up, there's a regimented follow-up, but in follow-up, how do we most effectively use invasive advanced imaging? You don't just send somebody to a bone or whole body CT because you have a hunch, right? There's variability there. And so what we did was we took mammography images, built a CDS pipeline, trained a model, and we're able to give decision support back to those medical oncologists to support them in saying, well, do I want to image this patient or do I not? Because the earlier we can identify recurrence and follow-up, the better the patient outcome. So I'm really going to focus on FHIR in this topic, on this project. And if you want to talk to me about the modeling, feel free to get in touch with me afterwards. So here is the architecture we used for clinical decision support. We started with the on-premise medical record system, and then we used the Google Cloud system for building this out. We would upload the medical records transformed to FHIR into cloud storage. We would also upload the DICOM images there, and we would process those with a cloud function into both a managed FHIR API and DICOM API. And then we trained a model on those labeled images, and we would use a cloud function to process new DICOM images that came in, apply the model to it, and deliver the prediction back to the point of care. So what we made here was essentially a cache of the EHR record in the FHIR format. And some of the things that we came across were, obviously, if you're going to make a high frequency cache of a very large medical record system, you do not want to have a chatty API. A patient record can easily have 10,000 or more resources, and this is just intractably slow. What you want to do is you want to send the patient bundle to your FHIR store and have it import into the expected state in one go. And it's nice to be able to stream partial updates or complete patient records. In a little bit more detail, how we did this was we started with extracting and transforming to FHIR on-premise. We would upload the complete FHIR record as a single bundle, and these were about 10 megabytes per patient. We used the finalize event in the cloud store to add a message to a FHIR ingest pub subtopic, and we did this to kick off a cloud function that would process it, but we didn't connect the cloud function directly to the FHIR or to the cloud storage event because you want to be able to requeue and reprocess without re-uploading. And then finally, we would import that FHIR bundle into the FHIR store with a client-generated ID. And why do I say client-generated ID? We would actually create the ID of the resource from the identifier in a deterministic way. So we would take the token form, which is system bar value, and we would hash that with the SHA-1 function to give us the ID. And this actually has a few benefits that will come in handy later, but one of them is performance. So like I said, these are a 10 megabyte bundle, and we initially used the bundle execute function, which executes a bundle into the store, and used the transaction flag on that. So in this case, the server generates the IDs, and for a 10 megabyte patient file, it would take 5 to 10 minutes to ingest. And of course, you could roll this back, but because this is a cache of the medical record system, and the medical record system is the source of truth, you're not too concerned about transactional rollbacks. You really can always flow the most current state from the medical record system into the FHIR cache. You also had to pre-process for referential integrity, which it didn't add that much time, but really what we found was using their imports feature, which was really meant to take a FHIR store from somewhere else and bulk import it into a FHIR store in GCP, we could actually get a 4-second per bundle load time. And again, here you actually have to client specify the IDs. But not all of your resources are going to have identifiers. Those of you that have worked with the spec know that the spec oftentimes takes what might be a single record in a EHR system and breaks it out into a hierarchical set of resources, oftentimes referenced, and sometimes your store might not allow you to use a contained resource. So you end up giving like an observation off a diagnostic report, an identifier that is not based on an EHR identifier. And so these child resources, as I call them, can produce a problem in your update cycle. So on the left here, if you have your diagnostic report and practitioner, which both have identifiers, and you have an observation that does not, when you update your diagnostic report, you end up with that original observation unreferenced. And that makes it harder to go and find those and clean them up. You start having to do graph queries to find those things. Better is to simply version your resources and then go back and clean up the older versions later, because they still have the references and the linkages intact. You can go back and save space, or you can keep the version history, either way. Another interesting part of this project was that we essentially did a federated ETL for integrating different systems, and where we actually put the DICOM Vendor Neutral Archive and the FHIR store together was actually in the cloud. So most of the FHIR resources were created on-premise and uploaded into the cloud. We also uploaded DICOM instances, and DICOM instances are aggregated into series, and the series are aggregated into a study, and we have the ImagingStudy resource to denote that. In this case, we wanted to both aggregate all the instances for a series, as well as link to the diagnostic report that the radiologist described those images. And so how we did that was we uploaded the DICOM instances into cloud storage again, and we uploaded about 120,000 DICOM instances for this project. We again used a GCS finalize event to add the message to the DICOM store in pub subtopic and processed it with the cloud function. The cloud function first would load the instance into the DICOM store, and then it would turn around and query the DICOM store for all the instances with the accession number that we got out of that instance's metadata. With that set of information, we could aggregate the DICOM instances into a series and into a study and import that resource into the FHIR store. We also were able to use that accession number to link, basically to deterministically create the identifier for the radiology report. And so really this kind of federated ETL really leveraged our ability to create references based on internal EHR information, because we could deterministically create the ID. One little thing to be aware of is with a STU3 imaging study, they were using a more restrictive OID data element for the instance UID, and they fixed that in R4. This was key. The OIDs that were coming out of our system did not actually match, so we had to hack around that. So really the takeaways are, for performance, you can really improve that with deterministic client-generated IDs in your FHIR ETL. You want to version your updates to avoid orphaning your resources. Federating ETL really enables integration. So having a plan when you create your identifiers and